Hello, everyone. This is Q&A with A&V. I'm Vincent Racaniello, and joining me tonight from New York, Amy Rosenfeld.
Hello, everyone.
Sorry.
It's okay.
This is Q&A with A.
Hello, Amy. How are you?
I'm fine. How are you?
I'm all right. I spent the day at the incubator. And
What's up with the Brooklyn accent? You're not from Brooklyn.
I spent the day at the incubator and had a nice live stream this morning.
Good.
It's first session of Virology. It was good, and a lot of people who were there were people who come to this live stream. It's excellent.
It's great.
I wanted to show people a little image, which I mistakenly already put up, of the incubator. This is where I was sitting this morning, not with the lights on, with just this one video light, of course, and I have a monitor across the room in front of the camera so I can see, and I'll be looking into the camera. This will eventually go on a stand, not on this cabinet here. And this is actually the editing desk that's going to be on the other side of the room. It'll be replaced with a different desk for recording. This wall will be covered with a sound blanket. And Amy helped me put up these sound panels on Saturday, right, Amy? It was just this past Saturday.
Yeah.
So thank you, Amy. This was her idea to get these colors, to put them horizontally and vertically. And if you saw the logo for Virology Live, you see now where the colors come from. And that was all her idea. So thank you for that.
It's good.
Did you have any formal design training?
No. I've never taken an art class in college. After, like, whatever art doohickey you do in elementary school. That ended it. That was the end of it.
So we now have some more moderators. When you make someone a mod on your channel, they go on to whatever you do. So in addition to Frank P. and Vanity Nutrition, thank you. Vanity was there this morning. I don't know about Frank. But we have also Mr. Ozzy Cam from Down Under. So thank you, Mr. Ozzy Cam. And as I go through the comments and find others, I'll thank you as well if you are here, actually. So let's get started with science questions. A lot of people did enjoy it. I want to see the half-cow woman painting smallpox anti-vax painting reaction live. That's what I'm waiting for. Okay. That'll be there. Oh, here we go. Steph is another mod. Thank you, Steph, for your assistance. We needed more mods today. There's a lot of questioning. Here we go. Elena wants to know your thoughts on Slavitt's podcast today, Amy.
So I thought Catherine Wu was good. I think she has a lot of good points. I think she and Andy have a lot of good points about certain things. About the overselling of the vaccines and their efficiency, how we don't say that we're wrong, and we open the doors to skeptics, and it's not always the most well thought out what we say and everything. So I thought she had some really good points.
Should we get her on Twiv?
Yeah. I think she and Ed Young probably would be a good pair for Twiv. Come together as their colleagues at the Atlantic.
So. Yeah, Ed was scheduled to come on Twiv some time ago, and then he had to cancel at the last minute. It was that episode on long COVID.
Yeah. Yeah, I think that they have interesting things to say. Not sure, like, she has a PhD in microbiology. He does not. So she at least gets the immunology and stuff. I mean, a few of the things that she tried to say about, like, the measles vaccine were slightly off, but the point was good. She tried to make a good point, but it was slightly off.
I'll wait a bit before having her, just to make sure people don't think that we're just having her because Andy Slavitt had her, you know.
Yeah. I mean, he has his own agenda.
Yeah. Amy and Vincent, what are the biggest unanswered questions in virology that you each have?
You can go first.
Well, let's see. I would like to know the trajectory of evolution of virulence of viruses. What
It's going to be
happens?
different for everyone.
Yeah, we don't know for any of them, though. So I would like to know when a virus first jumps from a non-human animal to a human, what is the virulence like? We know what it is for SARS-CoV-2. And then many years later, what happens to it? Does it remain the same? Does it go down? And as Amy said, it's probably different for different viruses, but we have very little data on that. And that's something I'd really like to know.
Well, how are you going to do that? How are you going to measure virulence of a virus, considering the fact that we now have physical interventions in like vaccines and masking. So how are you going to measure virulence of a virus?
Very difficult. Very difficult. And I think the only thing
Well,
you
what
can
is
do
virulence?
is make observations. Well, virulence is the capacity of a virus to cause disease.
So the only way you really could do this is if you had virus from now, and in 50 years you collected virus later
Yes.
and you put it in
Yes.
an animal.
That's
the
exactly
only way
right.
you can do.
That's the only way.
do
Yeah,
it.
you can make observations in humans, but that's not so good. I agree.
No, that's not. The observations in humans is not virulence of the virus because you have interventions.
What
So-
do you think is your biggest unanswered question?
It's the biggest unanswered questions in virology, I think, are like how, if you were to look at spillovers, why one animal versus the other animal. Especially if you use a different protein as the receptor. And then why one tissue versus another tissue. So PVR is all over the place. Why is it only in the gut? And I don't necessarily know that for so we slightly understand that, right, in the context of the interferon response, but not every virus is going to be regulated by the interferon response.
You don't have any basic molecular biology burning questions that you'd like to know about?
Basic
sure you do.
molecular.
I'm
sure I do. But there's also how does something go from outside the body or how do you get an antibody response and have it last so long if the entity is always considered outside the body? So stuff like that.
Yeah,
and
good
then
question.
of course that I have molecular biology questions.
It's a really
I
good
don't
question.
really understand. I don't really understand why certain regions of the genome are hotspots and are not.
Hotspots for mutation?
Yeah.
Okay. I guess
like for SARS-CoV-2 and SARS-CoV-1, if you said, or fate deletion is obviously a recombination event or something like that, right? Why is that a hotspot? Is it because the RNA structure is weird or, whatever? Because if it's supposed to antagonize MHC, then you wouldn't want to get rid of it as the virus.
Right.
So, but obviously it occurs quite frequently. So why is that? Yeah.
Yeah, here's Vanity. Thank you for modding this morning and now. Really appreciate it.
The other thing I'd like to know, if molecularly wise, is mutations. Why does, why don't RNA viruses have a proofreading enzyme component to it? Just SARS-CoV-2 does, and it's kind of okay.
Yeah.
But why doesn't others? And they, by definition, if you're 7 kilobases and you're making one mistake every genome, you have a way higher mutation rate.
Thank you, John, for your contribution. Coffee money for the studio. All right.
Very good.
What kind of controls do they do with cell cultures, Amy?
Do uninfected controls.
Could do uninfected, or if you're using a drug without the drug, or a different version of the drug, or if you're studying a mutant virus with different allele, with a different amino acid change, lots of different controls. The more the better, right?
Yep. So,
And
you
they're
know,
both positive. Go ahead. I'm sorry. Go ahead.
when I was a graduate student, there was a bacteria lab upstairs. She did like horizontal gene transfer. And you'll remember whose this lab was.
Mm-hmm.
Because they were one of the first labs to really do like phylogenetics and bioinformatics, and now he's at Penn, right? He's no longer here.
That's right.
And he worked for the Museum of Natural History for a while, right?
Mm-hmm.
And I once walked in and was talking to them, and like the PI came and said something or other, and I looked at them and I was like, "You have 19 wells on this plate filled. 18 of them are controls." It was like hysterical. It was the funniest thing in the world. I was like, "Where's the experiment?"
And we should also point out that they're both positive and negative controls, right? So a negative would be the leaving something out that you think is having an effect, and a positive is adding something that you think should have a similar effect to what you're looking for. So you don't always have a positive control, but if you do, you should use it, right?
Oh, for sure. I mean, you usually do that when you have, drug variants and variant proteins, right?
Yeah.
Excuse me, you compare it to the wild type.
Yep.
But I just thought that
That's
when
very
I
funny.
looked at the plate,
Yeah.
it was just hysterical. It's like,
It's very funny. All right. Who are the best science communicators working? Don't necessarily think I'm the best among the best even. I just happen to be a scientist who communicates. Let me ask Amy, who do you think is a really good science communicator?
I think it depends on the topic. You can't be good at all topics.
Sure.
I think Catherine Wu, because she has a PhD in micro and immunology from Harvard, she's very good discussing, infectious diseases, because she worked on tuberculosis as a graduate student.
Right.
And stuff. I think, what are you looking at?
I'm looking at my books to see who I have there. Do you think Laurie Garrett is a science communicator?
I think she has an agenda. So like she like I agree with a lot of what she says, but no, I don't really think she's a science communicator. So I listened to her on Andy Slavitt, and I listened to her when she was here on TWIV, and she, like, some of the stuff she said, and she didn't call when she was on Slavitt, she didn't call spike. She called it, she had a different name for it, like a probe or something. And she made a few mistakes that were very glaring. And it was like,
Yeah.
But I think she has some very good points about, like, the health department's not being run by MDs, and how we've pushed out all the public health people who've been trained in public health, and now we have these bunch of MDs who are making mistakes left and right.
Yeah.
And I think she's a good storyteller, but I don't necessarily know that she's a great science journalist.
Yeah.
I mean, because a communicator is a journalist.
Right. Well, I think,
and you're talking about, your field of expertise.
Yeah.
She doesn't really have a field of expertise.
I think her articles are very clear, though, and they do have an agenda, but I think they're clearly set forth, and she knows the stuff, even though, as you say, she makes mistakes from time to time. I happen to like David Quammen as a writer communicator. I think he does a good job, and he has a reasonable insight, and he knows who to talk to for the most part.
Well,
He is looking at he's writing a book on COVID. We'll see how that turns out, right?
yeah, but I mean, the people that he told you he interviewed are the people who have the massive
Yes, of course.
press
Yes.
presence.
Well,
Are
he did
they
interview
really the
me, and
right?
I don't
You
have a
have a
massive.
massive compared to Ralph and Susan. You have and Stan. You have a massive press presence.
Okay.
Okay, but if you're writing a book on the pandemic, don't you think you need to have Ralph, Susan, and Stan in the book? And I
I
highly doubt that they were interviewed.
yes, you're right. I think he did talk to Barrick though. Yeah. You said Ralph, right?
Yeah,
Yeah, I think he did.
but I mean, you really need to go back and you know talk to the grandmother, as she calls herself, the grandmother of the field, right?
Yes. So
Um, but a communicator is a journalist. It's like the guy on Squawk Box. He got tired of running his hedge fund. Now he's on television commentating about how the market did today and
yeah.
what he thinks is going to be projected as tomorrow. So this is the same thing, but for science.
Some people are nominating others: John Cohen, Kai Kupferschmidt, Helen Branswell.
She doesn't even have a PhD. What does she know?
Wait, you can be. Kwame doesn't have a PhD. Nicholas Wade. Oh,
Really?
Neil deGrasse Tyson is. That's a
Wait
different.
a minute.
It's a different
Nicholas
Wade.
Wade.
I think it's a different one, isn't it?
It can't be the different one. It has to be the idiot who wrote the article that David said was the smoking gun in.
Okay, if it's the same one, then that's bad. But I don't know who they mean. Alan Dove is in this list, and also Neil deGrasse Tyson. I think he's pretty good in his field. I mean, he has a
Yeah,
big
but
pulpit, right?
well, the stars and the planets are very sexy. Everybody
Yes.
likes the stars and the planets. They're very sexy. Look at all the people who are giving Bezos and whatever the Virgin Atlantic guy's name is. Richard Brafman or Branman, whatever.
Richard
Yeah.
Branson, yeah.
They're like giving millions of dollars to, circle the earth for 3 days.
I could use millions of dollars to,
Yeah, I could use millions of dollars to move my lab forward.
yes.
Would be the best of the best way to invest money.
Well, I would not disagree with you, Dr. Rosenfeld.
But Alan, Alan spends a lot of time, and I don't think he does every topic. I think he does certain topics.
Yeah, that's correct. All right, Adam is telling us that evolution is random mutation plus natural selection. That's right. It's correct, Adam.
Mm-hmm.
It's absolutely it. All right, Samuel is a primary special ed teacher who had COVID, got the Moderna shot. I know I'm well protected, but any chance I could pass it on?
It's quite the controversy now.
What do you say, Amy? Is there any chance, or do we not really know yet?
I think we don't really know. I think that a certain group in Wisconsin thinks that you can, and the Singapore study says that you can't. And I think that there's holes in both studies. And
Yeah.
so before we make any statements, you really need to do a lot more studies. But you also need to assess whether or not the people who you are testing as vaccinated actually made a response, and it's a consensus response where it's not like I made a blippy response and then it went down.
Yeah. Yep. H2 says, I'm in the Moderna vaccine trial. I got my shots in February. Now they're offering booster as part of the trial. The booster is half the original dose. Does this make sense?
Sure.
Yeah, I think that's fine. You probably don't need another same size boost, right?
Probably not. But like Catherine Wu really went about, like, she talked about this idea of, the boosting and whether or not we really needed a boost, and how, it's normal for you to get a big thing of antibodies, and then it wanes because otherwise your blood would be a glop and couldn't you really move through your body because it would be just so thick and viscous of all these proteins, right? And so she
Yeah.
comes out and she says, so we have this idea that we should have a booster. Okay, fine. And then she says, well, what is that really going to mean in the end of the day? Are you going to be back at the same spot in 8 months?
Didn't
Or
we say
are
that?
you going to
Didn't
be
we
a
say
little,
that?
yeah, but like she puts it in a way that like regular people can understand or whatever. So, you know, and Slavit really didn't think about like that. This is how the body works. You don't really want all these antibodies around, and you know, you're the end of the day, your booster's going to ask you the same question. You're going to come back in 8 months, and you're going to have the same question. And
Agreed.
you know, we needed to factor in time, and we didn't factor in time whatsoever. God, I wonder who said that the immune response takes time. I wonder, was that when we were discussing, like, should you get a shot 2 weeks after the first shot?
That was you, Amy.
That would be.
Thank you, Joshua, for your contribution. Pretty pens for the office. I'm a big fan of pens. I have 2 here. This one I bought in Japan. This one, see, this is a Pilot. So it's a Pilot which has a nice felt tip, right? Which I really like for certain things.
You used to like fountain pens.
I used to like fountain pens. And this one is very cool. This is a ballpoint. It is a Rotring. You can't really see because it's not in focus. Rotring. This is metal, really substantial, heavy. I love it. I have a pen addiction, for sure. Thank you,
now
Joshua.
You have a keyboard addiction.
Oh, yeah. I have a new keyboard at the incubator I just got. You want to see it?
Yeah.
Or are people not interested in my keyboard? I'll pull it up here and show you guys. Yeah, and now I have a keyboard addiction, which is substantially more expensive. Well, you can spend a lot of money on pens. Here's the keyboard. Let's share my screen. There it is. It's called the Royal Kludge.
What happened to the purple one? And why do we need a game? Yeah, the purple one. But why do we need a gaming keyboard? What is a gaming
I didn't even notice it was. I just like the switches are clicky and the colors. I have the purple one. That's here. That's right here.
Purple one.
This one. Do you like this one? Oh, I know which one you mean. Yeah, this one I designed myself. Kind of like.
Yeah, it's good.
The only problem with it doesn't.
I'm not sure what the red is.
It doesn't have up and sideways arrow keys, and I really use those a lot. So that's a problem. I designed a purple one. Yeah, I should get that made. I really like that one. Anyway, I have pens. Pens are kind of fading out of. I haven't bought a pen in a long time. I don't write that much, right? But when I write checks, I like to use a nice pen.
When was the last time you wrote a check?
I write checks all the time. I still send them in the mail, actually.
You use the mail?
Yeah, I do. In fact, I went on Monday on the way to the train station.
Wait, this is the actual mail, not I'm selling something from eBay and I
I dropped off a number of envelopes, a couple of absentee ballot envelopes. I had to send back my Easy Pass tags. They gave me new ones, so I mailed that. I mail things, yeah. I print, actually, I have microbe TV stamps. Did you know that?
No, I'm still astonished at the word I'm still astonished that you used the word I have stamps.
Yeah, I bought microbe TV. I had them printed, and you could put the postage on it, and you can get a letter with microbe TV stamps. I think they're very cool. Unfortunately, the post office has discontinued that service. Okay, Mike wants to know, what do you think the probability of SARS-CoV-2 origin has to do with white-tailed deer?
0.
Yeah, 0. As if you listen to last Friday's TWIV where Amy was on, quite clear that receptor binding domain of spike is harbored in bats. That was from Laos.
Yes.
Not deer. The deer are viruses that have gone back from humans into deer. That's quite
Yeah.
clear.
What I think is interesting is the fact that we're going to find out that you're never going to find a single cave with all of the pieces. It's going to be piece from here, and then you're going to move like 1,000 miles or 1,000 kilometers. You'll find a piece over there. Then you'll move 1,000 kilometers in a different direction. You'll find a piece over there, and eventually, it's never going to be in a single cave.
Right.
I think we need to get over this idea that it's going to be in a single cave.
Thank you, H. Zoo, for your contribution. Is CAR T therapy possible to use to treat viral infections, or is it just for cancer?
Not acute infections, but for HIV.
Yeah. When you get T-cell exhaustion, right, and you can direct them against an antigen. Yeah, absolutely. And people are looking at it for sure. Good question. Yeah. Is there any correlation with COVID vaccines and arthritis? I ask because my arthritis has worsened since having my shot of AstraZeneca.
Talk to Daniel.
It would make sense because inflammation caused by a vaccine could exacerbate arthritis, which is an inflammatory condition, right?
Could be, but I would still talk to Daniel.
But I don't know. Yeah, I don't know if there's a general correlation with it or not. This is the first time I'm hearing this. Right?
Yeah.
BJR2, thank you so much. 2 PharmDs in San Francisco. Attend, enjoy, transcribe, and disseminate your valuable information as best we can. Thank you. I really appreciate it.
That's great.
We have quite a following in San Francisco. And at some point I will go there to drum up funds. Jeff would like me to go out there and meet some potential donors. So I will go, and perhaps we'll have an event. Is that okay with you, Amy?
Sure. Have some sausage.
Oh, Bruce's sausage? All right. Kang asks, are there any indications that common cold coronavirus infection protected some individuals against severe COVID-19?
No.
Remember Karate postulated that last year?
Yeah, 100 years ago. It turned out no.
We haven't seen any evidence.
I believe that they're cross-reacting antibodies. I don't believe that they're cross-reacting neutralizing antibodies.
No, that's correct. That's absolutely correct. And there's some T-cell epitopes as well, right?
Yes, but I don't think it's well defined. I don't think it's well established for the T cells. Because this is not a pandemic about T cells. This is a pandemic about spike and B cells.
How would you define gain of function? I think gain of function is creating a new phenotype by any method, including breeding. That's right, a new phenotype by any method, breeding
I was going to say I don't understand what the method, with the mechanism of how you convene or convey the new function to. I don't know why
the method doesn't matter. No.
Yeah, I don't know why the method's important.
And it can be passage, it can be mutation, genetic engineering, anything that gives a new phenotype. That's the simplest way. Yes, absolutely. Has there been biodistribution studies on where in the body the vaccine-induced spike proteins travel? Not in humans, but in animals, yeah. They basically pump rodents up with huge excesses of lipid nanoparticles, and they find them everywhere, as you might expect, which was something they had to do for getting these approved. You need to know where they're going. But in humans, the dose is much less, so I doubt it's
well, it doesn't necessarily, when you give such a bolus, it doesn't necessarily mean that that's where it's going.
Right.
That's the problem.
I love Amy's very excited face in the picture and her completely relaxed face when the live starts.
It's cute.
What study determines the correlates of protection for a given virus? Well, it's a correlation, right? If you want to do it in humans, you have to see levels of antibody in people and whether they're protected or not. As Amy said before, early after the vaccines, were trialed, we had high levels of antibody in the blood and very, very high protection. But now we're in a more physiological state, and so the levels go down. And you can ask what levels will protect you. The problem is, what are you going to measure? Protection against what? All COVID? Infection? You have to define it. So currently we don't have a correlate of protection for antibodies. And if you say the antibodies decline from this to this, we don't know what it means because it could still be protective. We have no idea.
Well, you just focused on the antibodies because that's the easiest thing. But the correlates of protection could be defined by the T cells.
Sure.
So
Absolutely. Although, as Florian Kramer said in his review article about correlates of protection, T-cell assays are hard to do, so they're not as clinically useful as neutralization assays, which are far easier to do, right? Have there been...
once you have the T-cell epitope, why is it not as easy?
Well, you have to take...
You do an ELISA for interferon gamma production.
Yes, but you have to take T cells from patients and culture them. And that's the tricky. You're doing cell culture, so that's tricky. Whereas you just take serum and add it to virus is much easier. I'm sure you could get it to work very easily, Amy. But
we're going to do it for our viruses and our mice, right? That's the next. If we get this grant, that's like the grant in 18 months, right? To start to do that.
Have there been studies showing for how long the body produces spike proteins after receiving vaccine? Again, not people, but experimental rodents mainly, and I believe it was for a few days, and then they no longer make protein.
Right. Gets cleared.
So everyone likes your colors, Amy.
It's good.
Looks great. Are you going to use the green panels as green screens? No. We would, if we wanted to do green screen, I would just put a green sheet behind me, but I'm not going to do that. Yeah, the LED, that's a really nice LED light, and it's paid for by you guys, so thank you. There'll be some others coming in. Thank you, LB, for your contribution to the incubator and science communication. Why do you say viruses don't mutate? Isn't evolution mutation plus natural selection? I didn't say viruses don't mutate. Adam, you need to listen. I was criticizing the headlines which say the coronavirus is mutating. Why is that a headline? It's like saying the earth is round today. Would you like that headline in a newspaper article? The viruses are always mutating. What's important is whether it makes a difference. First, if it makes an amino acid change, because not all mutations do, and then whether the change has a phenotypic effect. That's what I'm talking about. I didn't say the viruses don't mutate. Absolutely not. Why are there no traditional inactivated COVID vaccines in the U.S., Amy?
Because that's not what we funded. We didn't take the bet that would be easily made and fast, easy and fast to manufacture, do safety, and make a vaccine available. And probably we have a bad taste in our mouth from polio. Very few inactivated virus vaccines are actually made.
So do you think it was a decision to try something new? mRNA and adenovirus vectored vaccines, for example?
Well, adenovirus has been used for 100 years, right, as a vector.
Well, not 100, Amy. Virology is barely 100 years old.
Sarcasm, Vincent. Don't be ridiculous.
Okay.
Don't be pedantic.
Okay. Ridiculous. All right. Adenovirus vaccines have been used for a while, and then mRNA vaccines have been tested for a number of years.
So I think that there was actually like a bit of a conflict of interest, but that's okay.
Okay. How best figure out the quality of research? For instance, the early reports on higher viral load in Delta versus later that it is not that different. Just give it time. Well, you could listen to Amy, who figures it out right away, or you could wait and see how it sorts out. As someone wrote into TWIV, when they hear it on TWIV, a few weeks later they hear it in general, in the general press and so forth. So Amy is often quite spot on. And all of these stories she has criticized, and she's been right this whole pandemic pretty much. You need to have your own Slavit type thing, right?
I know. When am I going to have time for my own Slavit type thing?
Well, you have to have it as a career, no? Would you like to do that?
You want me to give up research. So you're saying to me I'm a bad researcher.
No, how do you connect those two? I didn't say you were a bad researcher.
Well, why would I want to give up?
I just finished saying you're brilliant, and then you extrapolate because you could be.
I don't know. I don't think I would be good
No,
at it.
I think you should do research. Absolutely.
I don't think I have the temperament. Like he went like somebody would come and say that X, Y, and Z, and I'd be like, really? Did you think this through? Because that's wrong. Like, it's good that this isn't. He's not a scientist. He's a businessman.
Slavitz.
Yeah, he's a businessman.
Yeah.
He went to Penn. I believe he got his MBA at Wharton. He's a business person.
So, Amy,
He's not a scientist.
when the pandemic is over, is his podcast going to be finished, or is he going to do other topics?
I would assume that he'll move to like how to make, universal health care, or, how to do better global health and, stuff like that. How to like make, we talked about it when I was on TWIV in October, right? When you and Condit thought that there would be a lick a stick at the end of the year, and my response was, in 6 weeks. Remember that?
Yeah, I remember.
And then Alan, and then the paper that we did beforehand was about Nigeria. The snippet was about Nigeria and vaccinating people, and the needles and stuff. And Alan was saying how there was like no network, and I said, well, if you were going to actually vaccinate the entire globe for SARS-CoV-2, then we needed to build this network. Well, we still need to build this network.
Do you think we should have Slavit on TWIV?
He's not a scientist.
No, he's a communicator, just to see what he's thinking. I agree, but we mainly do scientists. That's true. Okay, fine.
I mean, he gave a talk to he was saying this morning, so he opens up with his podcast with a little monologue, and he said how he went to the National Academy of Sciences yesterday to discuss communication and stuff. And I'm sitting there and I'm thinking, really? They contacted you?
He's very prominent, Amy. I am not
Well,
prominent.
yeah, I understand. I understand he's very prominent. I also understand he's leveraged, he's leveraged his connections to, having worked for Obama as the Ebola czar or whatever he did, and then being head or part of the Biden transition task force and being part of the White House and all. I understand what he's leveraged.
As you also said last time, he's also charming, right?
He can be. I mean, he starts, everybody knows about his kids, about, he gained some weight because he sat on the couch. They know, like, all about his wife and his 25-year wedding anniversary. And, it goes on and on and on. Like, oh, he hurt his shoulder and then he couldn't move. And then he went to, PT and, men are big babies. And I was like, seriously? This is like, it's
we
5
already
minutes of this crap.
we know we talk about pens and keyboards. It's the same idea, right?
Well, I don't talk about pens and keyboards.
You talk about fashion. You talk about wine.
Periodically.
You talk about the Met Gala periodically. If someone asks you can get into other things for sure.
Yeah,
and
but I don't start off with a monologue about my 25-year wedding anniversary.
Well, we start off with a monologue about the weather on TWIV, I guess, right?
Right, but I don't.
No, you're very terse. You get down to business. All right, look at this one, Amy. Since every expert prediction in this pandemic has turned out to be wrong, could you please say, quote, I predict we'll all be still wearing masks this time next year, end quote.
Could you please say? I could say it. Sure, I can say I predict we'll all be still wearing masks at this time next year. I said it. The question is, do I believe it? Right?
Do you believe it?
I'm the person who said the pandemic would last 5 years. You guys put it together.
Yeah. Amy's probably right. You know, as I've just said, she's often got the insight, so you should listen to her. There's a reason she's saying the things she does, and if you want to know, ask her. Hello, Marty. I saw you on the Virology Live. Yep, 4 hours. It's a lot of virology. I'm very impressed that many of you are here for both the mods and many of you. Wow. It's pretty cool.
It's great.
Vincent, measles vax, etc. makes sense for kids since it notably affects them, but COVID vax, where in recent controls had more long COVID than COVID. I don't know what you're saying. Delineated 250,000 kids a week are being diagnosed with COVID in the U.S., and you really don't want to vaccinate against that? I don't understand the logic. What am I missing, Amy?
He's still stuck on the fact that people at the beginning of the pandemic came out and said, kids don't get infected, kids don't transmit, kids don't get disease. And we all know that kids come home with runny noses all the time. And I have yet to find a respiratory disease that is not transmitted by kids. And we also still continue to make the same mistake where the only people we're interested in are those people who have symptoms and fall into certain categories. And children don't present symptoms in the same fashion as old people do. And so unfortunately, when you have those preconceptions, then you get these questions about why should we vaccinate kids? And it's very hard to walk back what others have said, especially when they have more power than you do. Next time they should think more prudently before they say anything about that.
How about Mercola getting a smackdown from YouTube and playing the martyr? I wasn't
Mercola?
aware of this. He's the #1 anti-vax guy.
Oh.
And was he kicked off of YouTube? Good. Let him play the martyr. You know, all politicians play martyrs when they get caught, right?
Yeah. What is he really? He's a politician, or he's an MD, or what is he really?
I don't know what he is. He's not a politician, no. But he's been doing this for years, spewing anti-vax nonsense.
Yeah, I know.
How much is physics and how much seasonality? How much is physics? How much is behavioral? Has this pandemic given cause to reevaluate that for other respiratory viruses? Oh, I think. Let me know what you think, Amy. I think that a good part of seasonality is behavioral as well as environmental, for sure. Because in the winter, people behave differently, and
For sure.
And the weather is different also. What you think? You agree with that, Amy?
Yeah, but I think you have to define what you mean by seasonality. So, like, for picornas, at least the ones that we look at, right? It's a late summer seasonality in our climate. But the closer you get to the equator, it's an all year round disease.
Mm-hmm. Yes, correct.
So you have to be very careful about how you're defining it.
Yeah.
You know? Has this pandemic given cause to reevaluate that of other respiratory viruses? Reevaluate that. What is that? Seasonality for other respiratory viruses?
I believe so, yeah.
So, no, I don't believe that the seasonality of other respiratory viruses is going to permanently change. I think we have seen that, RSV and paraflu and stuff, their seasonalities after lockdown were altered and elongated because we had such a large population of immune naive people. But once we go back to the equilibrium that we are always at, it will return to where it normally is. And they will all be winter diseases again.
Agreed. Oh, this is an interesting name. Back to the science. It's good. Could you please explain why developing vaccines for herpes is challenging and if you think we can overcome the challenges? Well, people tried inactivated vaccines and they didn't work. Then they tried glycoprotein. There are 6 or 7 or 8 glycoproteins in the herpes virus particle, and they don't know which one. There's not one spike that they can say this is it. And they've had trouble with those. So I think that's part of the issue. But I do think there will be one at some point. I know David Knipe at Harvard was working on a type 2 vaccine. I believe it was an attenuated vaccine for Africa specifically because it's a problem there. I don't know how he was on TWIV a number of years ago and said it was looking good, but now I haven't heard anything. What do you think, Amy?
Didn't Bill Jacobs, the tuberculosis guy, think he could make a vaccine? Didn't Saul go talk to him about it and come back like super excited and then?
Yes, that's right. He was using TB to.
Yeah, and it was like GD and GE or something.
Yeah, that's good. That's a good point. I remember that now. Yeah. Yeah. So back to the science. It'll get done.
Well, I also think it's hard. So it's latent, right? And there's no. So you would have to always vaccinate people early in life before they get exposed. And I think depending on what herpes virus you're talking about, exposure is very early in life. Like what is it? CMV?
They're all really early. And the other problem, Amy, is if the vaccine doesn't prevent infection, then you'll get latently infected, right?
Yeah.
So
I'm not sure that you can make it I'm not sure that the paradigm shouldn't be that of HPV, but I'm not sure how easy that is to do for such a big virus.
And part of the issue is that when you have latent herpes viruses and they get reactivated, say, the virus encodes immune antagonists that suppress the T cell response long enough that until they're shed and move on to another person, and then the infection is quelled, but it's too late. It's already moved on. So it's a tricky situation. Yep.
But also, if I remember correctly, there's really herpes, traffics in the neuron, right? And then it goes back down the same neuron. But I don't remember there being markers on the cell surface for when it starts to traffic out. No,
because remember the ICP47 gene prevents antigen presentation on the surface.
Right.
It suppresses, so that's why the infected cells are not recognized by cytotoxic T cells. Yeah.
And then it's just the axons that innervate the external part of the skin.
Ooh, an RNA world question. Is it possible that RNA world self-replicators are still floating around in the oceans, but we just don't know what to look for? Sure. Absolutely. Why would they have gone away, right?
I don't know.
RNA is everywhere.
Yeah. It's 8:48, and I need to add my antibody to the MyELISA for tomorrow. So I can do 2 more.
All right. Here's number 1. If the infection fatality rate was, say, 10%, what is it, less than 1%? Would the anti-folk change tunes? Is risk tolerance the root of our division? It determines behavior and hence pandemic duration. No obvious answer, I know. Thoughts? This is an Amy question.
Well, so at one point, 30,000 people were dying a day? Or something or other, right?
In the U.S., you mean?
Yeah.
Yes.
Right? And we had 300,000 infections, so that is 10%, right?
Well, that's case fatality rate, right, which is an underestimate. But the infection fatality rate is a statistical extrapolation of the actual
right.
fatality rate.
But my real point is that at some point in this pandemic, we had 300,000 or close to 300,000 new cases every day and between 20 and 30,000 deaths every day, right?
Mm-hmm.
And we all thought, and while you and I did not think that this was acceptable, this country thought that that was acceptable. Because at the same time, the governors and senators and things were saying, we should just open up our economy. We don't need to mask. There's no need for masks and stuff, right?
Yeah, yeah.
And so right there is your answer. The anti folks didn't change their tune. It didn't the American public didn't blink.
I also think that a lot of it was politically driven. Certain politicians said it's not a big deal, and people believe them. That's it.
Well, it doesn't matter whether how it was driven. At the end of the day, the American public, out, outside a very small percentage, did not really blink. It was
All
an
right.
acceptable number.
Okay, here's the last one. Washington Post. Natural immunity to COVID is powerful. Huh? Karate says antibody B T cell vary by 100-fold independently in natural infection, although infection followed by vaccines give very broad immunity. So the question is, why does the Washington Post say this where Karate has said it's heterogeneous?
Well, it is heterogeneous. It doesn't mean that it's not powerful.
Yeah, in some people it can be powerful, right?
Well, obviously, in a lot of people, it's very powerful because we're saying that the best protected people are those people, and the people who have the best broad spectrum of antibodies are those from natural infection.
Right. But it's heterogeneous. So if you get a single vaccine dose, then you level the playing field, right?
Not necessarily. Why would you level the playing field?
Well, no,
you got a single dose of virus.
Oh, yes.
Why,
Okay, so you've said that before. It doesn't mean that they're going to respond. Yeah, the same people.
I don't know
got
why
it.
you. Yeah, I don't know why you would.
Okay,
level
here's the last
playing
one
field.
for you, because I know you like this. Will this
Okay.
coronavirus's genome be integrated into our own? I knew you would like to take this.
Are they smoking weed or something? Have
No, I
they
think he's
dropped a lot of
serious.
acid?
No. Mark has probably seen it in the press and wants to know. So tell him the answer.
It's an artifact. It's a paper that should be retracted because it's completely wrong and an artifact, and they should be voluntarily turning in their PhDs. It's so appalling.
Okay.
No,
Is that it? Yeah, I agree. It was an artifact, a cellular artifact, which can't be, apparently, it's too nuanced for certain journalists to pick up. And I'm not insulting all journalists, but
it's too nuanced for certain retrovirus virologists to have
yeah, I
picked
mean,
up.
that's the problem. The scientists are pushing it through also. You know, they're wishy-washy.
One of your textbook authors pushed it through.
Yeah, I know. It's unfortunate. So see, folks, I blame the journalists, and then Amy says not just them, the scientists are the ones talking to them, and she's absolutely right.
Yeah.
All right, Amy.
All right.
Thank you so much.
All right. Are we
See,
doing stuff tomorrow?
We're not, but we'll chat, I'm sure. Bye.
Bye. Yeah, I need to go finish. Okay, bye.
Bye. Some fully vaccinated people don't wear masks because they want to get infected with Delta. Idea is they are protected from serious disease and get a big boost of immunity. Question mark. Yes, this is the thing. People want to get infected, but you just don't. You're probably okay because you're vaccinated, right? It's not going to kill you. It's not likely to kill you. I just heard of someone today, a friend of a friend who was fully vaccinated, got COVID, was hospitalized, and died. However, he had severe other comorbidities, which probably, and we don't even know how his immune response was, right, to the vaccine. So, it's not 100% the protection. You could get really sick. So I think it's not a good idea to go out and get infected. Someone earlier in this stream, before I start, there are a lot of questions. And then when I start, those early ones disappear from my interface here. Someone said, I was vaccinated, I had my antibody level tested, and now it was 6 months later, it's gone way up. Isn't it supposed to go down? And I would say, yes, it's supposed to go down. Maybe you had an asymptomatic infection. Don't know. I don't understand why COVID couldn't have been a lab leak. The lab leak makes logical sense. Well, it doesn't. There's no data to support it, Kathleen. Zero. It's all innuendo. and, biases and whatever word I can think of. I have so much data that says it comes from nature. So, we've talked about this a lot. There are some TWIV episodes where we've gone through this. And I know there are people who are fervent believers of this out there. You can believe all you want, but you can't make up your own facts. And the facts are it came from nature because that's what the genomes say. Did you, by any chance, get my email about the case of rabies in Illinois? I did not. Sorry. But I will have a look at it tomorrow. A case of rabies in Illinois. We get them now and then. Hopefully they vaccinated the person, right? Because you do have time. Let's look it up. Rabies in Illinois. Man died for rabies after waking up to a bat in his room. Oh, dear. Man in northeastern Illinois died a month after apparently being infected by a bat he found in his room. He was in his 80s, woke up, found a bat on his neck. The bat tested positive, and the man declined post-exposure treatment, which would be monoclonals and vaccination. Okay, so he declined treatment. What was the point of declining treatment? So now he's dead and he can't take it back. Wow. Thank you, John. I guess that's what you're talking about. That's very sad. I am fully vaccinated. mRNA. Have a wedding in 2 weeks. Everyone's vaccinated with around 100 guests. Do you think a quarantine is necessary? No, there's no quarantine. You should. Maybe you want to test people before they show up. A few days before. But I think you're good. I presume you're not masking, right? Then you should do testing, yeah. Okay, Elena, my top 3 all-time favorite comedians. I'm not a big fan of comedy. But when I do see it, when I see good comedy, it's really good. So I'm not sure I can even do. You should ask Dixon, right? He's got his top 10 comedians. I do like, you see, I can't even think of his name now. I like George Carlin a lot. I liked Robin Williams. Is he a comedian? Would you consider him to be a comedian? I guess so. Who would be the third? I don't know. I don't know about the third. Sorry. I'd have to think about it. It's a good question, though. In someone with existing memory B cells, does the role of helper T cells differ from their role in an immunonaive person in the event of a new infection with the same pathogen? So it's an interesting question. If you didn't have the ability to make antibodies, well, you're saying helper T cells. Well, helper T cells can make cytokines that either help B cells or help cytotoxic T lymphocytes mature, right? So that would still be important to have those helper T cells around. And in a person without antibodies, then the cytotoxic T lymphocytes would be crucial for preventing death, right? So, there you go. Can you predict virulence from single nucleotide polymorphisms? No, unless you know that the change does regulate virulence. If you've already done studies and you know that, then you can say, oh, it's appeared in this virus and it's the same virus that you've studied, then yes. But no, if you see new changes arising in variants, you can't predict virulence. You'd have to do the studies. Just the same way you can't predict transmission. You have to do the studies, and they've barely been done for all the variants, right? Can you construct someone's social network with virus genomics? To a certain extent, I would think so, right? You can certainly track through sequencing viruses who has acquired the virus from whom, right? The extent of the network, may not be complete from that because not everyone's infected, right? But yeah, I think you could if you wanted to. Thank you, Rob. Appreciate your support. Today I listened to 277, my podcast, Vinny. Really enjoyed hearing VR history. In 2014, you said 5 years from now, I will no longer have a lab. Yeah, I did change my mind. But I don't think I'm going to have a lab in 5 years from now. Mainly because now I have an incubator, which could really take all my time, I think. I'm pretty sure it could. I can do a lot there. I mean, I've been there Monday all day. Tuesday, I went to Columbia in the morning to help Amy with mouse work, and then I went to the incubator. Today I was there all day. Tomorrow I'll be there all day. And Friday, so I have to go to Columbia to help Amy with mice. My goal would be to go to the incubator by 2 p.m. to record TWIV. So basically I'm recording and editing, and I'm still trying to sort out the physical incubator. Today, 3 chairs came in. Boom. FedEx delivered 3 chairs, comfortable chairs. I can sit on a comfortable chair now. Anyway, I digress. Thank you. That's an interesting point. Oh, here's a cool one. Is there a natural reservoir for polio? No, just humans are the only known hosts for polio viruses. Yeah. We don't even know where it came from, the origin, right? We think measles virus came from rinderpest, a virus of cows, about 15,000 years ago. We have no idea for polio. Jeremy England proposes the origin of life is related to an atom's propensity to regulate thermally, and life forms are supposedly optimal. I don't think that's right. I think life is an accident that arose down on the bottom of the ocean. You should read the books of, I can't remember his name. He's a British biochemist. He wrote a book called Oxygen, right? Let's look it up. Oxygen, Amazon, Oxygen, because I'm forgetting authors all the time. Oxygen is by, and then I get cans of oxygen. Come on, Oxygen book. Oxygen is a novel. God, I didn't know. Here it is. Nick Lane. Oxygen, the molecule that made the world. And he's got other books as well, all about the origin of life. He thinks the proton gradients, all life has a proton gradient. And he thinks they arose in these towering structures that rise on the ocean floor. Not the smokers, not those. It's a different kind of structure that rises and falls on the sea bottom. And it has seawater on the outside, and it has a different kind of water on the inside that comes through. It's got little chambers made of calcium, and he says it's the perfect place for a proton gradient. So I think that's what happened accidentally. It gave rise to energy, and it gave rise to life. That's what I know. You mentioned that once the narcolepsy caused by swine flu vaccine was only found a few years after vaccine rollout. Why aren't similar long-term effects? So the narcolepsy was quite controversial. I'm not even sure that we believe that it was correct. We did a paper on TWIV where the mechanism seemed to have been sorted out, and then it turned out to be wrong. It was all wrong. That wasn't a long-term effect, actually. It was following vaccination, relatively close to the vaccination time. It was associated with pandemics, a specific vaccine used in Europe. And it wasn't associated with any other flu vaccines, and it's been looked at quite a bit. So I'm not sure it's even, in pandemics in other countries didn't show increased risk of narcolepsy. So I'm just not even sure that that's an issue. Why aren't similar long-term effects possible? I don't think you can ever say that a long-term effect is impossible. All you can say is we don't really see anything. As Paul Offit said on TWIV, you don't see much after a couple of months. So I'm just going by what we know. I'm not saying it's impossible, but if you're worried, I would say that assuages the worry. At least for me it would, because we don't see these things. That's what I think. If you did indeed start a fungus podcast, would you consider naming it Fun Guys Talking About Fungus? No, guys is no good, right? We don't want to call it a guys thing, but that's very funny. I like it. Breaking news, YouTube is banning all vaccine misinformation from its platform to reduce the spread. Well, that's great. I hope they don't ban me. They think, oh, this guy's talking about COVID vaccines. He doesn't know what he's talking about. You know, they could do something like that, because here's my issue with YouTube. People take my lecture videos, they download them, and they repost them on their own channel. They take my name off of it, and then they make money. They put ads on, which I don't do. And I once complained to YouTube, and they said, you have to prove these are your videos. Give me a friggin' break. Prove that my name is on them. Look me up. Prove that you're... And that just pissed me off, and it was the end of that. So I don't trust YouTube to do the right thing, frankly. Okay? Because of that bad experience. Prove that they're your videos. I mean, I have the Creative Commons on them. You can reuse them. And I don't even care if you make money. But what the hell do you take my name off of them for? I made them. So that's why I stick on every slide now my name at the bottom. It's a lot of work to take. I just crop the whole video, I guess. It's not that much work. I don't want to watermark it. That would look like crap, right? All right. So enough of that. Well, that's good, Gnome Gardeners. I'm glad to hear that. Do we really know when it jumped to humans? No, we don't. We really don't know. Could it jump and be of low virulence until it recombined for a while and became more virulent? Yes. The key is for a while, right? Those words. We don't know long. It probably wasn't years. We think we would have picked it up on just surveillance. So I think we're talking about months at the most. Maybe October-ish 2019, it jumped into people, maybe a few months earlier. And we don't know for sure. We might know, but likely not. Hi from Sydney. Is autoimmune thyroiditis, Hashimoto's syndrome, a contraindication? I'm not aware of it. I don't know, actually. You should ask Daniel Griffin. Daniel at microbe.tv. Sorry. What do I think of some healthcare workers refusing to be vaccinated? I don't understand. They're healthcare workers. Why would they refuse to be vaccinated? You're supposed to be taking care of people's health, right? So you're doing the opposite thing. And they're threatening to quit. They should, because they shouldn't be in healthcare. I have nothing against them personally, but that doesn't make any sense to me. Can we give COVID to cats? Do we know if cats can give COVID to us? So certainly cats can get COVID. We know that right, the tigers in the Bronx Zoo can get COVID. And yes, so pet cats can get them. There's a Newsweek article 10 hours ago. China kills 3 pet cats which contracted COVID. Can they spread it back? Potentially, yeah. The mink that got COVID from people in the Netherlands looks like they spread it back to some people. You can tell by the mutations in the genome that mark them. So that's why you should get vaccinated, right? Then it's not an issue. SARS-CoV-2 vaccine, strong cell-mediated immunity, but the flu vax doesn't. That's right. That's what Ron Fouchier told us. Is this a function of vaccine technology? Yes, I think it is. The flu vaccine is old technology. It's grow up virus and break it up and then inject it. I just think we can do better than that. And you know, the flu mist is infectious, but it doesn't do any better. So could mRNA do better? Yeah, I think so. I think it gives you a nice bolus of antigen. It's just a matter of testing it, and I'm sure that'll be done. It's in progress, believe me. With the results of the COVID mRNA vaccines, you bet it's going to be tested for everything. It's not going to work for everything, but it's going to be tested. How does the antiviral pill do this winter work? Well, apparently there's more than one by several companies. I know the one from Merck is called molnupiravir. It is a inhibitor of the RNA polymerase of the virus, the enzyme that makes RNA. And it really does a good job at blocking virus production and preventing transmission. What I'm afraid of is that if we just use one, we're going to get resistance very quickly. Within months, we're going to have resistance to whatever antiviral pill we get, all right? But we're not going to use combinations to start because they're being tested singly. They're going to be tested singly, they're going to be deployed singly, and then only later tested in combinations, and by then it may be too late. So I think this could be a real issue. Stay tuned. Are you aware of any new data about onward transmission from vaccinated people? No, nothing new that I find convincing in any way. But if there is something, you will hear it from us for sure. Oh, you'll hear it in the press first, but we'll tell it to you. Why can't naturally acquired immunity be viewed as acceptable? Well, Amy has said that she feels it's acceptable, I believe. Now, Amy's listening. I know that tomorrow she'll listen and she'll let me know if I misquoted her. The problem with naturally acquired immunity, as we mentioned previously tonight, is that it's heterogeneous, more so than vaccine-induced immunity. You have a wide range, and Shane Crotty talked about this on his last epitope. You have a wide range of responses from very low to intermediate to very high. And in fact, Florian Kramer also talked about that in the TWIVO release next week. So, and vaccine-induced immunity is more homogeneous, so that's the problem. So you could say, if I'm infected, I should be fine, but you might not be if you didn't respond. Now, Amy would say, well, how do you know they would respond to the vaccine? And that's a valid point. So how are you going to do this? You're just going to say, I tested positive, so I should be good to go. You should have some kind of antibody test that measures antibodies at least, but we don't know what levels are protective. They don't have a correlative immunity. So that's the situation we're in. We're not ready to do that. Is there a practical way to test for all viruses one has been exposed to in their lifetime? Is there a way to date the exposures? So the answer to the first question is absolutely yes. We can test for all the viruses you've been exposed to. And in fact, there was a paper published a number of years ago, which we did on TWIV, where Steve Elledge was one of the authors. They made a virochip. They took a glass slide and they printed on it peptides derived from all of the known pathogenic human viruses, thousands and thousands of short peptides that were synthesized chemically. And then they flowed over this slide sera from people. And if you had an antibody in the serum that would bound a virus peptide, it would bind and you could detect it. So they could tell everything you'd been infected with, even very, very low levels of antibodies, which is what happens years after you're initially infected. So yes, we can do it. And they say it's cheap enough to be done on a mass scale. So I think one day we're going to have that. Is there a way to date the exposures based on some immunological response? No, we can't really date it because it's, beyond the first month or two where you see mainly IgM. After that, it's all IgG. We can't date it. No, unfortunately. That would be nice, right? With COVID vaccines suppressing killer T-cell receptors, may this explain the rise in shingles? Well, are you stating a fact that these... I don't understand where you're getting this COVID vaccine suppressed killer T-cell receptors. No, I think shingles reactivation is due to the insult of vaccination, the inflammatory response, right? Herpes viruses are reactivated by stress, and that's the stress response that is doing that. Trying to grasp rapid testing. Many tests require 2 tests. What info are we getting? What tests do people use for same day or school testing? Can we get a few minutes on that sometime? Daniel Griffin is always talking about this. Rapid testing can be accurate. He's talked about studies that have shown that rapid tests can be accurate. And typically they're antigen tests, right? So they tell you if you're making viral protein because the PCR test is too sensitive. And then You have a positive test, then it's cheap enough you can repeat it. And you know if that's a real positive, although many of them have a high positivity rate. So same day or school testing, it's a mix of antigen tests and rapid PCR tests. You know, some of the antigen tests you can do on your own, in fact, and so they're valuable. I mean, the idea last year was that everyone could have a very cheap daily test. You're positive, you stay home. The next day you test again. If you're negative, that's it. It was a false. Or if you're positive again, you stay home for 10 days. So the rapid antigen tests could change everything. They're only starting to come out. Although in Europe, we've had listeners write in saying that they're either free or very cheap. Game changer. Why? Because you can test yourself and know immediately. You're going to a wedding, everybody tests themselves the day before. If you're positive, the day of you test. If you're positive, stay home. They're brilliant. You're brilliant. Can you communicate why there's no Koch's postulates and how the vaccine was sequenced without it? No, there are two different things you're talking about here. So Koch's postulates we don't fulfill any longer because you have to isolate the organism, you have to grow it in culture, you have to put it back into the animal and show it causes the same disease and then recover it again. We can't do that with people. But what we can do is observe people getting infected. It's a natural Koch's postulate experiment. So that's it. I don't know what you mean how a vaccine was sequenced without it. I'm sorry. I think Gina Colada is very good. That's the right spelling, yes. I think I like her a lot. I think she's level-headed, yeah. I've seen data showing vaccinated breakthroughs don't spread COVID as much as unvaccinated, but still some is anyone looking to see if vaccinated spread much while asymptomatic or pre-symptomatic. So this is what Daniel Griffin has said, and Amy disagrees with that. I think the data are not very good. Don't spread COVID as much. I don't think any of those are really well enough controlled to determine that. They're small numbers. I think if there is any transmission after vaccination and infection, it's really, really low. Yeah, Drosten is a very good science communicator. Look at how he was embraced in Germany. He decided to do this daily thing, and he was embraced. I don't think if we did a daily virus report, we would be embraced in the U.S. to the extent that he was, because I just think in Europe they appreciate, or at least in Germany, they appreciate science more. Lots of people's favorite science communicators. So we got inactivated vaccine questions again. What's the news on Novavax? You'd love to have my opinion. I don't see any of the data. The last thing we saw were the phase 3. It was not even a complete phase 3, and it looked good, but we needed the final data, and it's not forthcoming. And I don't know why. I heard they had production problems, but they solved that. So I ask Daniel Griffin all the time, and he doesn't know. Would you expect a lower vaccine dose to result in lower T-cell responses? It really depends. It depends on whether the other dose, the full dose, is in excess or not, right? And if you've titrated it, and I'm not sure they have. So, if you cut it in half, it might not make a difference. Really hard to know. Okay, so we'll move through science communicators here. If you could go back to grad school, what virus research would you do now? Oh, so if I were going to grad school right now, gosh, it's really hard to get in science now. Funding is so tough. What would I work on? I'd pick a lab that's doing what I want to work on, right? Would it be COVID? That's what you want to know, right? I don't think so. I'd do something else, but what would it be? I don't know. Maybe I'd go to a lab that does field field sampling and look for viruses in rodents, say. I always wanted to do that in my backyard, but never did it. So I would do that. I would do field work, yeah. I would pick rodents. I'd like to know what viruses are in American rodents. That's what I'd do as a PhD thesis. Could go out and catch animals. That would be fun. Bring them back to the lab, sequence them. Yeah, that's what I would do. Other than the big pharma propensity for serving the rich, what other reasons are there for such inequitable vaccine dispersion? Well, big pharma is mostly in the big countries too, right? Because they have the economics and infrastructure to support them. So many countries don't have production capability. And the countries that make the vaccine prefer to use it in their countries. But there are many multinational companies. So AstraZeneca, I spoke with Sarah Graham, who's going to be on TWIV next week, and she said, AstraZeneca has 25 manufacturing plants all over the world, and that's great. And they're giving it out to people. So I really think it depends on the company. But I think the main issue is if you don't make a vaccine yourself, then you have to beg. And the smaller the country you are, the less impact you have in your begging, basically. Now, that's a simplification because I'm not an economist. I'm not a supply chain person at all. I just know viruses. That's what I know. My mother has MS, hasn't been allowed to take any vaccine for years, but for COVID she doesn't get a medical exemption. Does that make sense? She's afraid of taking it. I don't know why you'd have a medical exemption for MS to begin with. That doesn't make sense to me at all. I think that's a great question for Daniel Griffin. Can you send it to daniel@microbe.tv and I'll ask him? I really like that. Would a freshly jumped virus, that's a good one, change more quickly since moving to a new species would apply different pressures? Yes, kind of a punctuated equilibrium. That's what we call, so in the emerging virus paradigm, and if you take the live stream, Virology Live, we'll have a lecture where we talk about that. When viruses enter a new host, they tend to change more quickly. They're unstable. And West Nile did that when it came to the U.S., right? It had been in other parts of the world before, in humans, but now it encountered new humans in North America, and it underwent rapid change. And that is what SARS-CoV-2 has been doing, right? It's been changing rather rapidly since it entered humans. Yes, and then with time it settles down. It's not that there's no mutation, but it settles down. I don't think a communicator has to be a journalist or a PhD. Yeah, I agree. I'm not a journalist, and there are many communicators who are not scientists, excellent ones who are not PhDs. I totally agree with that. That's fine. But you better see a journalist is taught how to ask the right questions and figure out stuff without having a big background. But you can easily get misled, right, if you don't ask the right questions. So you can have great writing, but even Carl Zimmer makes mistakes. I mean, I make mistakes. Hell yeah. But when people make science mistakes and they shouldn't, I don't like that. They should know better. They should know who to talk to. You should have a stable of people that you go to and say, is this right or not? I just interviewed this person. Can you just tell me if my conclusion is right? And they say, oh, I don't have time to do that. BS. Fix it. Come on. First chance you get, what country do you plan to visit? Well, I usually don't plan. I usually get asked to go places. So is there something this year? I don't think so. But next year I'm going to Nebraska. Is that a country? No. I'm going to visit the University of Nebraska. And then I'm going to Switzerland in April. And so the trips all get lined up for me. I don't choose where to go. For after an mRNA vaccination, the spikes would be built by ribosomes inside muscle cells or antigen-presenting cells like macrophages and dendritic cells. Okay? So the dendritic cells and macrophages are really active at taking up stuff. And if they see a lipid nanoparticle, they're going to take it up. So I think that's the main target, because there are plenty of those in your muscle. And then they'll make the protein, they'll present it to T cells in the lymph node. Now, if a muscle cell picks it up, the spike will be displayed on the surface, and it can be sampled by a dendritic cell as well, for sure. But I think many of them go in the dendritic cell. Yeah, Albert Einstein was very good at explaining his ideas. Many scientists can be. They have to take the time to do it. Many scientists don't want to. And I'm lucky to have collected a bunch on my pods that want to do it. It's really good. So a question for Amy Vaccine. You have to ask her this. I think she would get one of the mRNA vaccines and just space it out maybe 6 months. Yeah, Alan Ald is another good communicator. Yep. Many of you were in the class this morning. That's great. That's great. More infections mean more mutations, so will more variants keep popping up until finally some kind of immunity holds? Well, I don't think it's going to keep going on forever. Let's take a look at the variant situation, okay? Let's look at covariance. Here we go. So I want to see an overall view. So here are the main ones they're tracking. Here is delta, of course. Let's see what mu is up to, because we know what delta did. And so mu is, what is the brown? Maybe if I hover over it, yeah. Colombia, 75% of all reported cases, but you can see it's going down. But probably just the frequency of infections are going down. And then, Curacao, Costa Rica. So mu hasn't really done very much. It's not really the one I wanted to see. The one I wanted to see is the world in data, right? Which has a really nice COVID variant. Let's see, vaccinations, testing, blah, blah. Where are the variants? There is a variant. Anyway, I can't find it. I don't want to take your time, but I don't think we're getting continuous rapid emergence of new variants. But I agree that fewer infections will lead to fewer variants emerging. I don't know if we've seen the last or not. It's hard to predict that. Flu varies every year, right? So this could certainly do the same thing. Got the Moderna September 3rd. I'm thinking of waiting 6 months before getting the second. I think that's a good idea. I think the 6 month interval allows the antibody response to mature. In your lymph organs, lymph nodes, and spleen, the B cells keep making different kinds of antibodies, and they get better and better just with time. They've seen the antigen, and now they go on for a while. And I think 6 months is a good time to let that go and mature, make high affinity and broadly neutralizing antibodies. And then you boost, and it really seals the deal. Yeah. J&J, well, it's an adenovirus vectored vaccine, so it's an adenovirus particle. It's a virus particle with DNA inside. I wouldn't call it a DNA vaccine because it would be a naked DNA vaccine, right? My friend has 2 young boys who will be eligible for the vax once it's approved. She's very pro-vax. He's concerned about the reports about myocarditis. Yeah, the myocarditis Daniel Griffin's talked about. The incidence is low. It's much lower than myocarditis after COVID. It's completely treatable. It's completely detectable and treatable. In most cases, recover with no issues. So that's Daniel's words. So I think there's no worry there. Yeah, now a bunch of keyboard questions. I love keyboards now. Yep. And Darren came from Lex Friedman. Boy, the Lex Friedman is really getting a lot of eyeballs. That's really good. The MMR, measles, mumps, rubella, is an attenuated virus vaccine. That's right. 3 different viruses, measles, mumps, rubella. They're all infectious attenuated viruses made many years ago. Why haven't pharma made an attenuated? So attenuated vaccines take longer to make and test, for sure, because you have to attenuate them first, which is a process. It's not like you make mRNA and test it. You don't just attenuate. You have to figure out how to do that, which can take a while. And so that's why they made a decision not to make an attenuated, because it takes too long. Now, this is interesting because I'm on a NIH committee to do pandemic planning, like for different viruses. And they said, we don't want attenuated vaccines. We want you to come up with vaccines, but not attenuated, because they take too long. If we have a pandemic, it takes too long to respond. So that is the answer. 2 mRNA viruses walked into a bar. One had a Japanese pen. The other had a heavy metal pen. Trade you for a keyboard. I have it. That's right. That's what I have here. I have a heavy metal and a Japanese pen. And this is the keyboard I showed you, which I had designed. This is from WASD Keyboards. It's a nice company that you design it there and they build it for you. Now, the one I'm using now, look at this one. I didn't show you this one. So this, it's upside down, but that'll do. This is from a company called Novel Keys. They sell you just the bottom part, and then you have to buy switches and keycaps yourself. And so I forgot what switch is it. Probably Cherry MX Brown or Red. I don't remember. But this keycap set is called Matcha, right? Green tea. Don't you love it? And some of the keys actually have nice icons. I didn't use any of them. Since you're talking about keyboards, don't get mad at me for digressing, okay? Just chill a bit. I want to show you. So these things, you know, the keycaps come in these cool packages, right? And you can see some of them. So that one there is like a cookie, an ice cream cone, a chocolate, a cake. There's a cool one for the there's one that says matcha. Where is it? On the bottom there. See, that says matcha. I didn't use any of those, but they're pretty cool. All right. Sorry. When viruses jump from humans, are they always so competent to spread worldwide? No, I think there are thousands of jumps a year probably, and we don't see any of them. They're dead-end jumps for a variety of reasons. So I think the ones that do this or spread to any extent are very rare. Yeah. Can you elaborate on how memory B cells are ready for variants? So the idea is that when you get a spike, let's say you get the ancestral SARS-CoV-2 spike, it's recognized by B cells. They start to churn out antibodies that recognize it. Then with time, the B cells, as I just mentioned a few minutes ago, they begin to make different antibodies. There's a process called somatic hypermutation that goes on in the germinal center of the lymph node, where the antibody genes are mutated. Then new antibodies are produced with mutations in them, and if they're better, if they bind the protein better, they are selected for. So you can imagine that some of these mutated antibodies could bind a spike that it's never seen, right? And that's how they can be ready for variants. So if you recover from COVID and you get one dose of a vaccine, you make antibodies that hit all the variants that are out there, plus SARS-1, MERS, coronavirus, incredibly broad. So the combination of infection and one boost, one vaccine dose gives you that kind of broad antibody response, because now you have, for some reason, the double exposure prods the germinal center B cells to make all kinds of antibodies. So that's what's happened. That's what one of our guests said. I think that was Shane Crotty. spike. The J&J vaccine is an adenovirus genome encoding spike only. That's correct. You saw my comment in the National Geographic. I don't know what I said. I talked to so many people. We're just talking about microbe TV stamps. There are some reasons why I have to mail letters. It's not a problem, folks. All right. In the 2-shot injections, in your opinion, would there be any difference in using alternate arms? No, not at all. I don't think that matters at all. I think that they can go back and forth to different lymph nodes for sure. A lot of vaccine questions, not really questions, but comments. You know, you guys are chatting. That's great. Yes, I will be in San Francisco because there are some potential donors there that I should schmooze with. So I will let it be known when I'm coming. What happens if someone gets a very small doses of coronavirus? Would this microdose produce some degree of immunity? It really depends on the extent of reproduction. If the virus is eliminated in a few days because it's a small dose, then no, you're not going to get much of an immune response. So it really depends. But it could be that a small dose in a certain person who has poor innate responses, the earliest responses, actually reproduces very highly. So it really depends on the person. I will someday get to New Zealand and Australia again. I have had an opportunity to go before, and I'm sure I will again. What's the difference between Delta and Delta Plus? And additional changes. You can go to covariance.org and look at the exact up. It's just another mutation or two in addition. Why did Pfizer's effectiveness drop from 90s to 40? Well, it didn't really. It dropped in all. Well, first of all, I don't think the data are correct. I think the analysis is wrong. And I think that the effectiveness against severe disease and death remained in the 90s for both vaccines. Even though the press takes it that way, I don't think it's correct. I think a lot of these observational studies are wrong. And I've heard many scientists say that. And you're going to see, if they go to peer review, then they don't get published because many of them are wrong. And the problem is we're getting preprints released, the press reports that they're fact, and then they're wrong. So this is a problem, right? Thank you, Margaret, for your contribution. Really appreciate it. Can I furnish you with the ingredients? I can't, but Moderna will. It's on their website for sure. Absolutely. Is long COVID caused by cytokines? I think so, yeah. I do think so. You have an imbalanced cytokine response that causes some long-term damage, and I don't know exactly what it is. But we'll find out. People are working really hard on it. But I do think it's all cytokine-based, yes. Thinking of starting a family, I'm hesitant of taking the vaccine. I'm afraid of long-term effects for our future child. Well, you're going to get vaccinated, and then you will pass on your antibodies to the child and protect it when it's born. I think that's a good thing. The vaccine's not going to get into your child. Get the vaccine before you get pregnant, and by the time you do, the vaccine will be gone. There's nothing to worry about. I don't see the science behind your concern. Did SARS-1 skip past the upper and only infect the lower tract? No, it infects the upper tract. Viruses all start in the upper tract. They very rarely go all the way to the bottom first. It's a low probability event. They start in the upper tract and they move down. The problem with SARS-1, or it's not a problem, the good thing was when you were shedding, you were really sick. There was no pre-symptomatic shedding. And when you got sick, half people were in the hospitals where they could stop transmission pretty easily. So that's why one of the reasons we were able to stop transmission of SARS-1. Why not an antigen test rather than PCR? Well, neither are actually detecting infectious virus, right? But the PCR is detecting genomes, and unless you quantify it, because if you don't have a lot of genomes, you're not going to be transmissible or contagious. An antigen test is just simply to know if you're infected, because when you have viral proteins, it's likely that the virus is reproducing in you, right? Because the genomes don't have to reproduce to give a signal. So the antigen test for viral proteins, not antibodies, is good to tell you very quickly whether you're infected or not. One doctor said myocarditis, other symptoms may be due to not aspirating. No, Daniel Griffin says that's not true. It has nothing to do with aspirating. Even though 2 shots is highly effective, why not get the booster? You can get it if you want. There's no downside that we know of. Yes, you could get long COVID from an asymptomatic infection. We don't know if that's the case. The incidence of long COVID after vaccination, then infected, isn't known. And I agree that you I understand that you're concerned about that. And if you are, you can get a booster. I'm not getting a booster. I think the vaccines protect you against serious disease, and I don't feel there's evidence for long COVID. But that could change. If I saw the data, see, I'm data-driven. I don't want to do things unnecessarily. And that's where I'm coming from. But I don't tell people not to get a booster. You can listen to what we say and make your decision. Thank you, H-Sue. Are you able to get the money out of YouTube? No, still not able to. It's in there. I mean, it's okay. It's there. I have to keep trying, and I've been rather busy these days. But I'll do it. How does the HLA-B27 target conserved peptides? Because the B27 apparently is good at recognizing variant peptides that are generated during long-term chronic infection by Hep C, and HIV actually is the B27 also. So it really recognizes a variant peptide which wouldn't be recognized by other HLA molecules. Thank you, Ralph, for your support. Really appreciate it. I think I really enjoy it, and I have to say, look, I've been a research scientist all my life, and now and then I'm sitting in the incubator. I say, what am I doing here? Am I a fraud? Because people have called me a fraud, but not for communicating, for being a virologist. And then I quickly realized, no, I have all you guys here enjoy what we do, so no fraud here. But thank you. Be pedantic. Yeah, I'm often pedantic. Now, look, I understand what Amy was saying. So she said adenovirus vectors have been around 100 years. I didn't want people in this live stream who have no knowledge of virology to think that that's true. I know she was exaggerating, so that's why I corrected it. And she said, don't be pedantic. So I think that was a case where I had to be. Okay. Is it possible that some individuals are genetically impervious to contracting COVID? Yes, absolutely. 80% of transmission is by 20% of people, so that's one thing. And then, yes, some people do not get COVID. I think they have genetic predispositions, and we don't know why, but absolutely, yeah. A change in spike that is radical enough to make our vaccines completely ineffective would also almost certainly be so extreme as to make the virus non-functional. Yeah, Sarah Gilbert said that. I don't think you could say that. You don't know. I just think you don't know what changes. I mean, I agree that many changes make the virus non-functional, but I don't think you could conclude that. So what is to make our vaccine completely ineffective? That would mean the T-cell response would have to be ablated too. So maybe that would be a dramatic change in the spike. It wouldn't just be one change. All right, so it's possible, I would say, but I wouldn't conclude it which seems to be what she is doing. I'm interested in CD8 T-cell responses since SARS patients, so T-cell responses 11 years. Do you think we'll see more vaccines targeting CD8s? Yes. The T-cell epitopes are a bit more conserved, and yes, I think next generation vaccines may include more T-cell epitopes. I've heard vaccine manufacturers talk about it. Welcome, Frank. Thank you for joining us again. Frank is another one of our moderators who I've been pointing out here. Now, Les is also a moderator. Thank you, Les. Les was at the lecture this morning. I'm not calling them lectures. They're sessions because they're different. Virology Live, because you guys can talk among yourselves. If you're in my class, you couldn't talk among yourselves. But here you can. And that's what makes it different, and I think that's what makes it cool. Thank you, Joaquim, for your contribution. Money. Excellent. Anybody are captive colonies of bats just not significant enough to research? So the problem with captive colonies, you need them to do certain things, but the bats are not flying. And during flight is when they generate the oxygen radicals that or their immune systems have to protect them against, and which we think is why they're really good at keeping viruses in check. So you can never reproduce that state. So it's limited. But still you can infect them, you can make cells with them, and it's really important. Does an increase in transmissibility or fitness equal more virulence or pathogenicity? Not necessarily. They could be two independent properties. Now, it could be that, let's say, you select for, somehow a virus is selected for that makes more infectious particles in a cell. That virus could be more transmissible, so that would be the main selector for it, perhaps. But it might also be more virulent because making more virus particles could cause more damage. Now, that's a hypothesis. Virulence in itself is not selected, in my opinion, unless it gives rise to better transmission, because I don't think killing people quicker is a selectable phenotype for a virus, but I do think that transmitting better is. All right, so this is about the amount of RNA in Pfizer versus Moderna. Could this be why it's waning more? I don't know. It's a possibility, but I don't think you can prove that without more work. So there's not much more on pets and their ability to spread. We don't know any more than we did. Dogs and cats can be infected. It doesn't seem to be very common. I don't know of any documented infection back into people, though. Yes, the rabies death. Can you define pathogenicity? The other day I had a discussion about this with my friends. One asked if you would consider a fungus as pathogenic if it grew on a fruit, you eat it and get ill. Oh, if it's from the fungus that you get sick, then yes, it's pathogenic. Pathogenic means cause disease, the ability to cause disease. So if you eat something, if you eat the fungus in it, and that is making you sick and not the actual fruit, then yes, the fungus is pathogenic in you, for sure. And viruses can be pathogenic, they can cause disease, or they can be not pathogenic, as we talked about today in Virology Live. This is not for me, that's for Jennifer. It's a virus vaccine. It's a DNA virus vaccine. A DNA vaccine is DNA only. That's just the terminology. You can't reinvent it, okay? We are getting a lot of the same questions. That's why I'm... Article today about molnupiravir. Didn't see it. Barron's is not one of the journals that I consult on a daily basis, but I'll have a look at it. Yes, indeed. And yes, someone asked if Amy will do the recitation. I asked her, she laughed. I don't think she will have time for that. But that would be fun, right? If she could do discussion sections with you. That would be cool, for sure. Yes, we are at 99,600 subs. I think that's cool. Thanks to all of you who have spread the word. And then we'll work on 200,000, right? Am I getting the flu vaccine? Well, what month are we in? Oh, yes, I need to get it. It's being made available now. I get it at the medical center. Yes, absolutely. Absolutely. Yes, so here's the thing about seasonality. It's trumped by lack of immunity. So when much of the population is not immune, as still is the case for people and COVID, then it doesn't matter what season it is, yes. But in other cases, normal situations, seasonality really is a thing. So don't let the pandemic cause you to reevaluate your thinking about seasonality. It's just that so many people are not immune that overrides any seasonal issues. Yes, the best science communicators are storytellers that can easily speak to 8-year-old high school student or a PhD. Yes, I don't tell stories. I try and make things clear. I speak from my experience, and I think that works. I do talk to young people as well, and they seem to like it. When does a person shed virus? For about, probably transmissible for 7 to 10 days, a few days before symptom onset, and then 7 or so days afterwards. Shedding peaks just at or slightly before symptom onset, and then rapidly declines. Very short window of transmissibility. Besides HPV, are there other sexually transmitted viruses that are prevalent in humans? Sure. We have cytomegalovirus, we have herpes simplex viruses, HIV, hepatitis B virus. Yeah, there are quite a few, right? Any helpful analogies to explain to vaccine hesitant as to how the mRNA vaccine works? Now, there have been many. And here on this live stream, I think Les had one that was really good, but I don't remember offhand. They should be collected somewhere so that I could look at them, because I will forget them. You know if there's any data on intranasal administration instead of IM? You know, I haven't seen it. I don't know if it's gone into people yet or if it's just in phase 1, but there are some in development, yes, for sure. Stop criticizing Amy if she got a number wrong, okay, folks? Sometimes people make mistakes, and it doesn't really matter. Now we're at the point where, yes, you can, thank you, you can all let it go now. You guys are really interested in seeing us make mistakes, but it really, we admit it when we do. Just chill. We're both incredibly incorrect at remembering peak death numbers. Both. And if you don't like it, just leave. I don't really mind. The people who want to be here are here. Yeah, CDC has issues. I agree. Masks will go away when we can show third doses prevent transmission. That is just wrong. That is just wrong. My immunology is a little rusty. Does the immune system benefit from exposure to pathogens? Yeah, it does. There are general boosts, but of course there are also specific boosts to pathogens that that happen if you get a flu vaccine and you probably get infected once a season, but you don't really know it, or maybe you get sniffles, and that gives you a boost. So that's a specific boost, and then there's a general boost as well. Is masking going to be an issue? I think it could be. We know that for RSV, respiratory syncytial virus, it already was. That there was an unusual season in Australia, a paper we did on TWIV some time ago, because you don't get the normal specific immune boosting that you would because of masking. And this year we'll see. I mean, maybe the flu season will be worse, but we'll see. That's really important. Absolutely. All right, we have 5 minutes. Let me see if I can find some super chats to thank. Thank you, Tamara, for your contribution. We do this. We run everything on contributions. The ads on YouTube I find are very disruptive. My wife watches farming YouTubes, and all of a sudden someone's explaining how to plant something, and then there's an ad. So if I were teaching and there were an ad, that would be disruptive. So I don't put ads in my videos. I never will, and I'm leaving a lot of money on the table, so I depend on people's contributions. And I think that people recognize that and are willing to support it, especially when we become a nonprofit, which should be happening any day now. Any chance that Alzheimer's is caused by a virus? I don't think the epidemiology supports that. Certainly, some of the pathology is very much like prion diseases, right? But I don't think... Yeah, but some people have suggested transmissibility is part of it. So I reserve judgment. I don't think we can say one way or another. Yep. Let's see. Here's another thank you to Bill. We try. We do make mistakes. We admit it. Just chill when we do, right? Thank you, Axis Audio. Pundit Kim Iverson said we should give up on herd immunity because Singapore hit the threshold and still has a rise in cases. It seemed pretty absurd. I don't think they've hit the threshold. I think if they had, they would see cases declining. It's just something is wrong with the calculations. Because I believe that... I believe herd immunity works, and we have evidence. Not that I believe it. I see the evidence that herd immunity works for other viruses. And please like us if you're here. We have 633 people. It's really easy for you to go down below the video and hit the like. I appreciate it. It helps spread the word. That is what we're trying to do, just educate people. Thank you, Ian, for your contribution. Ian taught me how to say kia ora, right? So did Andrew from New Zealand. Gretchen, I know you've asked this question many times. I don't think anyone has looked at the K for Delta. That's my understanding. How do you make a payment? Presumably someone helped Claire, but there's a little $ below the chat window there. You could go there. You could go microbe.tv/contribute. There are a lot of great questions here. Bring them back next week, and we'll get to them. I'm just looking to thank our contributors, because without them, we couldn't do this. Thank you, Mark. Is there a new test out called Circle Health Pod that claims to do PCR accurate molecular testing at home in 20 minutes? No, I think it could happen. Yeah, I don't know the details, Mark, of that one, but I'm not skeptical. No. Thank you, Sandy, for your contribution. Really appreciate it. And yes, I'm a scientist. I don't generally talk about treatments unless Daniel Griffin has asked it and answered it. And that's why I say, if you have a question clinically related, we don't know the answer from Daniel, send it to daniel@microbe.tv and we'll pass it on to him. We record tomorrow, Daniel's episode. And that does it for today's. I want to thank everybody for coming, all 653 of you. We got 341 likes. Thank you. Appreciate it. Come back next week. So Monday we have Virology Live at 11 a.m. Eastern. And Wednesday we have Virology Live 11 a.m. Eastern. And then Wednesday 8 p.m. Eastern Q&A with A&V. Thanks, everybody. Take care of yourself. Oh, one more thank you. Thank you for your contribution. We'll talk about that next time. Time to end the stream. Thanks, everybody. We'll see you next time.